Normally, in Rust, you can easily write unit and integration tests for regular synchronous functions. However, for asynchronous functions, things are a bit different. Here I have this add function and its unit test. This unit test makes use of a synchronous function and it works perfectly. However, if I make this async, we get an error. But when I inspect the error, you can notice that this errors because the result variable is a future and not a U64 integer. For those familiar with JavaScript, a future is like a promise. When you call an asynchronous function, it returns a future. You then have to await it to get the result. To solve this, I will await the future and now the result variable is a U64 integer. But right now we have a new problem. Await can only be used in an async function, so we have to make this function async. When I save this, another error appears and this says that async functions cannot be used for tests. To fix this, we'll have to make use of a very popular crate called Tokio. In this project, I will add the Tokio crate and set its features as full. When this is done, I will go back to our project and this time, instead of using the regular test attribute in Rust, I will use the test attribute from Tokio. The error disappears, meaning that we can actually use async test functions. So far we use the test attribute from Tokio instead of the regular test attribute. If I run this function, it passes as it should. So how does this test attribute from Tokio enable us to run asynchronous functions? Well, if you already have an idea of what the Tokio crate is and what it does, this will be very easy to understand. But if you don't, the Tokio crate is a very popular Rust crate that allows you to easily and efficiently run asynchronous and multi-threaded programs in Rust. The test attribute from Tokio is an attribute macro, and this converts this code here to this. So under the hood, the test attribute macro creates a separate thread and then blocks the thread to run this async block. Since each test function runs on a single thread by default, if you spawn multiple worker threads and try to run them together, they will run concurrently on the single thread and not in parallel on separate threads. When two tasks are running concurrently, the runtime switches back and forth between the two tasks, making it seem as if they are running simultaneously. When two tasks are running in parallel, they are executed at the same time independent of each other. So as this test is right now, when you spawn two threads, they will run concurrently. For example, here I have spawned two threads where I print hello 3 times in the first and world in the second. I then try to run both tasks simultaneously. Since this test function runs on a single thread, the runtime will always print hello before world. The only time it will skip to the next thread is when it encounters an await. So let's try to run this and see it in action. When I enter cargo test, I will follow with 2 hyphens and then a show output flag to display the print messages in the terminal. When I run this, you can see that hello comes before world, and no matter how many times I do this, hello will always be printed before world. If you want to run a test function with multiple threads, in the test attribute, add the argument flavor equals multi-thread. You can also specify the number of threads by adding worker threads equals your desired number of threads. In my case, I will set this as 4. Now, if I run this a couple of times, you can see that at times, world displays before hello. So in summary, if you need to run multiple tasks in parallel or have a function that needs to run multiple tasks in parallel in your tests, set the flavor to multi-thread. When you do this, instead of the new current thread, the new multi-thread method is called. If you specify the number of worker threads, the worker thread method will be called and its value will be passed as its argument. In standard Rust, we have some assertion macros which we make use of in our tests, but when working with asynchronous programs, there will come a time when you would want to verify that your asynchronous function should be pending and not yet resolved at a certain time, or your asynchronous function should be resolved at that time or should resolve but with an error. You may only encounter this in multi-threaded asynchronous programs, but when you do, you will need some special assertion macros for that. These are available in an external crate called Tokio Tests. I will go ahead and add this crate to the program to show you how this works. Now here I have a function called authenticate that may look a little complex but is actually a simple procedure. In the first line, I created a channel using the MPSC module from Tokio. A channel is one of the ways two threads can communicate with each other. The value 10 in the parameter is the buffer size. This means that the sender can only send 10 messages at a time. When the buffer is full, the sender will have to wait for the receiver to receive one of the messages before another can enter the channel. Next, we have an async block, and inside this block, the receiver listens for messages from the sender, which is the password. If the password is correct, it returns the secret data. If not, it waits for another message until the sender is dropped. Then it returns an error. This function returns both the sender and the async block. They can then be sent and executed in different threads. I will drop a link to the repository for this codebase in the description so you can look at this in depth after this video. To test this function, I will extract the sender and the future from the authenticate function, then import the task module from Tokio test. Be sure this is imported from Tokio test and not Tokio. From the task module, I'll call the spawn function, and this opens a thread and marks the execution of this future. When this sender, also called the transmitter, sends the wrong password, the future should still be pending, waiting for the correct password and should not be resolved yet. To assert that it does, I will import the assert pending macro from Tokio test. Now, in the assert pending macro, I will call the poll method on the task, and this returns the state of the future. When I run the test, it passes since the future was actually pending. There is also an assert ready macro which asserts that a future is ready. If I use this macro to test the poll and run the test again, it fails since the future is pending and not ready. The assert ready macro returns the data from the future if the future is ready. I can then assert that this data is actually what I need. So before the assert ready macro, I will send the correct password and then run the test. When I run the test this time, it passes. You can combine the assert ready and the assert EQ macro by using the assert ready EQ macro. Here, I will pass in the poll at its left and the data at its right. I will remove the previous assertions and test again, and this works as we expected. There is also the assert ready OK and the assert ready air macro, which you can use to assert that the data is the OK variant of a result or the error variant. For the assert ready OK macro, you only need to pass in the poll. I will remove the assert ready EQ macro and test again, and the test passes. Now, to test the assert ready air macro, I will create a new test function and repeat the procedure in our previous test. Instead of sending a message to the channel, I will drop the transmitter. From the authenticate function, if the transmitter gets dropped, the channel closes and it should return this error. I will test if this works by using the assert ready air macro. This takes the poll from the future. When I run the test, it passes. As a bonus for this video, sometimes you work with timeouts and intervals in your asynchronous code. To properly test these functions, you may have to sleep the thread for the desired amount of time. For example, here I have a function that times out a future after 5 seconds. This timeout function from Tokio creates a new future that wraps the other future. This new future will be pending until the other future resolves. If this future is not resolved after the specified duration, which is 5 seconds in this case, the timeout will abort the future and resolve with an error. To test my timeout future function, I will create a future that will always be pending. The future module was imported from the standard library. When I spawn a mock executor thread, I will call the timeout future function and pass in the future. For the timeout in this function to resolve with an error, I will have to wait for 5 seconds. But before that, I will assert that the timeout resolves with an error. When I run the test, it fails since the timeout is still pending. For this test to pass, I will have to sleep the main thread for 5 seconds, waiting for the timeout in the other thread to resolve. When I run this test, I will have to wait for 5 seconds before I can get my results. In a practical project, you may have a lot of these which may accumulate and slow down your test, but thankfully there is a way to solve this problem. In your Tokio test macro, add a start post attribute and set this to true. When I run the test again, this time it finished instantly without waiting for 5 seconds, and on top of that, our test passed. What this does is that whenever we call the sleep function, it fast forwards the time by the sleep duration, making the sleep to resolve instantly and then move to the next procedure. Since the sleep duration was 5 seconds, the time was fast forwarded by 5 seconds, making both the sleep and the timeout in this function to resolve. If I change the sleep time to 2 seconds, the time will only be fast forwarded by 2 seconds. This means that the timeout function would not be resolved by then, so it should still remain pending, making the assertion here fail. When I run the test, it fails as expected. To get the code used in this video, you can go to this repository on GitHub. I will drop a link in the description and the pinned comments. Thanks for watching.